Hello, my name is Prasharati, and today I'll be telling you about the features of quadratics. Let's get started. So, there are four features of the quadratic function that we want to know how to find today. These are the roots, or zeros, the vertex, the y-intercept, and the concavity of the function. They are all on this graph. I'm going to try to show them to you right here. So the roots are these 2 points where the function intersects the x-axis. The vertex is this point, kind of the tip of the function, the min or max. And the y-intercept is this point, essentially where the function intersects that y-axis. We'll talk a little bit more about this later, but for now, we're going to know how to find these features with 3 common forms of a quadratic function, as well as a sort of bonus formula that will derive from the quadratic formula. So with all that said, let's start by talking about the roots. So, how to find the roots? First of all, what is a root? A root is essentially an x value for when the quadratic function in question intersects the x-axis. In other terms, it's what x equals when y equals 0. There are usually one or two of these roots present in a quadratic, though some of the roots could be complex numbers involving I. For now, all the quadratic equations that we deal with will have roots that do not include I, meaning that we can tangibly see them on the graph. There's 2 conventional ways to find roots. First is the good old quadratic formula. We'll use it when we have an unfactorable quadratic equation that is in standard form or can be easily converted into standard form. As a quick clarification, standard form is ax squared plus bx plus c. Let me write it down. Ax squared plus bx plus c. And forgive my handwriting a little bit, but you'll see a lot of quadratics like this. The other way is to factor. We'll use this when our quadratic equation is easily factorable and can or will be easily converted to standard form. Essentially, an easy factorable quadratic is a nice quadratic equation that factors into whole numbers that are kind of nice to deal with. So let's do a couple of examples to get a feel for it. First, let's use the quadratic equation to find the roots of x squared plus 8x plus 2. So let's write it down. X squared plus 8x plus 2. So let's figure out what our a, b, and c terms are, and then we can just plug it into this equation and figure out our roots. So our a term is going to be 1, since there's no coefficient next to x, but we know that x squared exists, so we can imagine that there's a 1 next to that x squared. Our b term is what's going to be next to that x, so we see that there's an 8 and it's positive, so b will just be 8. And our c term is going to be 2, it's that constant term. Okay, and now we're going to just plug this all into our equation. So we'll get negative 8 plus or minus the square root of 64, that's 8 squared, minus 4ac. So a is 1, c is 2, so 2 and 2 times 4 is 8. So 64 minus 8. Over 2a, a is 1, so we'll just have 2 on the bottom here. And now we could simplify this and we can have our roots. Our roots can just be defined as negative 8 plus the square root of what I think would be 56 over 2, and negative 8 minus the square root of 56 over 2. So factoring, let's try to factor x squared plus 7x plus 12 to get a feel for it. Okay, so to factor this, I need to find two numbers that can multiply to get 12 and add to get 7. And since there's less numbers that multiply to get 12, I'm going to examine all of those numbers first to see which one of them adds to get 7. So the first combo of numbers that I think can multiply to get 12 is obviously 1 and 12, but if I add them together, I get 13, and that doesn't work. So let's try a different combination. My next one is, let's say, 2 and 6. If I add them together, I get 8. We're getting closer, but that's not exactly right. So let's try our third combination. Let's try 3 and 4. So 3 and 4 do add up to be 7, so we know that those two are our magic numbers. So let's put them into our factored form. So 3 plus, x plus 3 times x plus 4. And our roots, since this is technically in a quadratic equation, so this whole thing would be 0, our roots would be x equals -3 and x equals -4. And that's done. So let's move on. So how do we find the vertex? Well, first of all, a vertex is when a quadratic function reaches its minimum or maximum point. And this distinction depends on the concavity of the function. There's two good ways to find the vertex. First, we can use the averaging root formula, which is derived from the quadratic formula. It's the one that we talked about at the beginning, to find the x-coordinate of the vertex of the function. We'll want to use this when our quadratic is or can be put into standard form. Otherwise, we can complete the square of the function. We can use this method when the quadratic function is or can be put into standard form, or when our quadratic function is already in vertex form, which we'll elaborate on later. So let's do a couple of examples with vertex. So our averaging root formula is -b over 2a. And let's first do an example where we try to figure out the x-coordinate of the vertex of x squared minus 6x plus 8. So our b term here is -6. As you can see, it's the term next to the x. And our a term is going to be the term next to the x squared. And that's going to be 1, because we can imagine that there's 1 next to this. It wouldn't change the value of x squared. And if we plug b and a into our little equation here, we'll get 6, because it's -6, and those negatives kind of cancel out. And we have 2a, so we'll put 2 here, and we should get 3. 3 is the x-coordinate of the vertex of our function. Now if we wanted to find the y-coordinate, we'd plug in 3 into this equation. And let's see, 3 squared is 9, minus 18 is -9, plus 8 is -1. So we'll have 3, -1 as our vertex. Now completing the square. Let's try to complete the square on x squared plus 8x minus 3. So completing the square is a little bit of a different process. Essentially what we want to have is a perfect square and then a constant on the outside. So we have x squared plus 8x. Now let's imagine that we're making a quadratic function out of just x squared plus 8x, and we need a constant term at the end. If we wanted to have our function kind of be perfect, like only have one root, we would want it so that we have the same thing multiplied with the same thing. So x plus a times x plus a. And what we define a as is essentially half of this second term. It'll be 4. So let's say we wanted to make this into x plus a squared plus a constant. What we would do is we would have x squared plus 8x, and to complete this square, as denoted by the name, we would have plus 16. We would want to add 16 because if we had our a term as half of this term, that would be 4. That means that we would have x plus a times x plus 4 times x plus 4. And now our b term is correct, but our c term would be 4 times 4, which is 16. And since we're adding 16 to one part of the equation, we have to subtract 16 from the other part of the equation to make sure our equation is still the same, right? So let's write this all down. So we'll get x plus 4 if we complete our square, and we'll have a little squared symbol here. And since we've added 16 in order to complete this square over here, we need to subtract 16 from here, and since we already have minus 3 here, we're going to have minus 19 on the edge. And that's completing the square. So this is actually vertex form. Vertex form is essentially where you have the x value and the y value in a way where you can plainly see it. So if I wanted to actually find the coordinates of the vertex, what I would do is I would take the negative of this value here. I see I have 4, so it would be negative 4. And I would have negative 19. So negative 4, negative 19 should be my vertex. Can I do a little box around it? Yep, okay, and let's move on. In case you want a better way to memorize or derive the average and roots formula, here's how you do it. Essentially, you're trying to find the average number in between two roots. So you want to write one quadratic formula, but instead of the plus or minus, we're just going to put a minus sign. So let me just write it down. So negative b minus the square root of b squared minus 4ac over 2a. And we're going to add that to the other quadratic formula, but this time we're going to have a positive sign, or a plus sign. So negative b plus the square root b squared minus 4ac. Okay, just extend that, and we're going to add that all over 2a. And remember, with our averages, we add the terms and then we divide by the number of terms. And since there's 2 terms, we're going to divide by 2. Yeah, forgive my sloppy writing. But if we want to simplify this algebraically, we'd see that we'd have negative 2b up top, and our square roots would actually cancel out because we have minus a certain square root plus a certain square root, and they're the same, so we wouldn't have anything of that at all. And since the denominators are both the same, the denominator will be kept the same on the bottom. We'll just have 2a. And since we're dividing by 2, it's essentially the same as multiplying by 1/2, so I'm just going to put a 1/2 in the corner here. And I can just cancel out my 2's in the numerator and the denominator, so I will get negative b over 2a. Isn't that great? And if this is too much to derive, if you forget the formula, easiest way to remember is if you look at the quadratic formula, you just need to pick the first term from the numerator and put it over the first term from the denominator. Negative b over 2a. Okay? And let's move on. So, how to find the y-intercept? It's essentially where the quadratic function intersects the y-axis, or what y equals when x equals 0. There's only really one way to find the y-intercept, and it's converting your quadratic function into standard form, and then finding the constant, or number without a variable, and this constant will be your y-intercept. So let's see this on a function, let's try it on x squared minus 3x plus 2. You can see that my constant term is 2 over here, and it's plus 2, so it's going to be positive. So that means my y-intercept is going to be 2. So my y-intercept is actually going to be at 0, because it'll always be at 0, and then 2. Okay, and that's it. So let's now find the concavity. Essentially, concavity is whether the function opens up or opens down. It's either concave up or concave down. I like to think of concave up as like a smiley face and concave down as a frowny face. Like uplifting spirits and down in the dumps. A little bit of a weird way to characterize it, but yeah. But the nice thing about concavity, it's one of the easiest things to find because you can find it in every single form. You can either check the a term of the quadratic in standard form, check the sign next to the parentheses in vertex form, or check the sign of both x's in factored form, and I will show you in the next slide. So, standard form. Let's try it on negative x squared minus 2x plus 8. So since I see a negative next to my x squared term, that means that this function is concave down. And that means on this graph, I don't exactly know how this function looks like because I haven't calculated the roots, but I know that my parabola is going to open down. It's going to look like this, upside down U shape. Now let's practice vertex identification on, let's practice the vertex form identification on x minus 2 squared plus 9. So since I don't see a negative next to my parentheses, I know that this is going to open up. So it's going to look like a nice U shape. And finally, let's practice this identification on the factored form. So let's do x plus 6 times 7 minus x. I see we have a positive x here, but we have a negative x here, meaning that if we multiply this out, we'd have a negative x squared, meaning that our function is concave down. So it'll kind of look like this top function in the sense that it will also be that upside down U shape. Okay, mini quiz. Don't panic, just take this as a quick self-check to see if you were paying attention. If you don't get how to solve this, take a quick break and rewatch this video. Don't beat yourself up about it. This stuff might be news to you, and that's completely fine to take a little bit more time. So, what is the vertex of x squared plus 6x plus 8? Pause this video to figure it out. Okay, you're back? Awesome. So there's two ways to do this. I'm going to complete the square because I personally like that method a little bit better. But as always, both methods work perfectly fine. It's all up to preference. But anyways, so completing the square on x squared plus 6x plus 8. What we want to do is we want to take half of this b term, that's going to be 3. So we're going to have an x plus 3 squared as the first part of our vertex form. And since our last term, since we're going to be adding 9 to complete this square, since we're going to have 3 times 3 if we multiply this all out, we want to subtract 9 from the end. So since we have 8 minus 9, we're going to have -1 at the end here. And now to find the vertex, remember we always want to take the negative of that term in the parentheses, so it's going to be -3. And we're going to just take that term outside, that's going to be -1. And that should be our vertex. Okay, we're done. Thank you so much for listening and have a wonderful rest of your day.